Okay, Assalamualaikum warahmatullahi wabarakatuh. We will continue. Okay, last time we have talked about Newton's universal law of gravitation. So today we are going to continue about gravitational acceleration. Okay, and then we have learned that gravitational force is also known as universal force because any two bodies will experience the force. Okay, so what is gravitational acceleration? Okay, according to Newton's second law of motion, gravitational force can be expressed as F equals to mg. And then you may ask, why mg? Why not ma? Okay, because when involved gravitational acceleration, we use the symbol g. Okay, then from Newton's universal law of gravitation, gravitational force is expressed as g m1 times m2 over r squared. So what is the relationship between gravitational acceleration and the constant g? Force equals to mg, and then gravitational force equals to g m1 times m2 over r squared. Then we equate them and we cancel the m's and we get g equals to gravitational acceleration equals to g times me over r squared. And then we want to know whether there is a variation between gravitational acceleration and the distance. So you may do this activity in order to understand better the relationship between gravitational acceleration and the distance. Okay, so calculate the value of gravitational acceleration for the 5 distances and complete the table. So if you look at the table, so I have calculated this for you. Okay, if the distance is r, so we have gm over r squared. And then when we have 2r as the distance, we have gm over 4r squared. And then if the distance is 3r increases, and then we have the gravitational acceleration as gm over 9r squared. And then you calculate for 4r and 5r, and those are the answers. And then we may ask questions. What is the value of gravitational acceleration on the Earth's surface? Okay, and you can also draw the graph. You can draw a graph from this data. Okay, I don't use numerical values. I use alphabet gm and r squared. So how is the graph look like? Okay, so when you plot the graph, okay, so this is what you will have graph. Okay, and okay, this is the maximum value of g, gravitational acceleration. So that is when the distance is r. So here we see value of gravitational acceleration is directly proportional to the distance from the center of the Earth for r less than value of capital R. Okay, for radius less than r. And then what happened? Okay, and then we plot the graph. Okay, if you look at the if you look at the graph, so the boxes, okay, is in can help you to understand, okay, the relationship. What does that mean? Okay, so look at this example. So if the distance is 5r, so the gravitational acceleration is gm over 25r squared. So let's say we have 25 boxes. The value of gravitational acceleration is just 1 over 25 of the boxes. So we see that the gravitational acceleration reduces as the distance increases. Now let's look at a few examples of daily situations.